start the session.
Well, thank you very much. I'm just going to quickly do a microphone check with everyone. Can everyone hear me? And can you see the presentation? Please feel free to type in the chat box if you can hear and see the presentation. Okay, excellent, good stuff. So hello everyone, my name is Jason Mays. I am the developer advocate for Tensorflow.js here at Google over in California. And what that basically means is if you're using machine learning in JavaScript, there's a good chance that I will magically appear at some point. Yes, a little bit about my background. Essentially, I've been using JavaScript for pretty much half my life. If there's one thing you take away from the slide, is that I've been using it for a very long time. I actually started out my career as a web engineer, went into full stack web engineering, and then moved into more experimental prototyping through my creative engineering route. So that's where I actually learned more about machine learning and augmented reality and all these emerging technologies. And then, of course, I moved into prototype engineering at Google, which allowed me to make these cool prototypes for companies around the world. And then that led me to my current path, which is developer advocate for Tensorflow.js, essentially combining my love for machine learning and web technologies all in one role. Now, you might be wondering, why would you want to do machine learning in JavaScript? And that's a great question. And essentially, JavaScript can run in a lot of places. First of all, it can be running on the web browser, on the server side. Oh, has someone taken over the presentation? 1 second. Let me just resume presenting here. Okay, so hope you can see my presentation still. Basically, we can run in the browser, on the server, on desktop, on mobile, and even on Internet of Things. So if we dive deep into each one of these stacks, you can see all the technologies that you may know of already. So on the left-hand side, you can see the popular web browsers that are existing right now. We run on the server side on Node.js, React Native for native applications, and we also support WeChat and progressive web apps, Electron for desktop native applications, and of course, Raspberry Pi for Internet of Things. Now, Tensorflow.js can run in all of these environments, and this is only possible because JavaScript is pretty much the only language that can run in all of these environments without any add-ons or plugins or anything else like that. So very, very powerful. Now then, essentially, if we look into the kind of benefits of using Tensorflow.js, we can, can everyone hear me? Sorry, I got a question about people not being able to hear me. Can you hear me okay? Yeah, okay.
Yes, we can.
Okay, thank you. So essentially, you can retrain via transfer learning, or you can write your own machine learning models completely from scratch in Tensorflow.js, just like you can do in Python already if you're using Python already. So much the same thing can be achieved in JavaScript land as well. And that, of course, means you can dream up anything you might want to, from augmented reality, sound recognition, sentiment analysis, and much, much more. So I want to talk about the 3 ways you can use Tensorflow.js right now. And essentially, this comes in 3 flavors. The first is pre-trained models. These are really easy to use JavaScript classes for many common use cases. And if we dive into these, you can see that we've actually got a lot of options here out of the box. So we've got things like object detection, body segmentation, which is basically where you can identify pixels in an image that belong to a human body. We've got pose estimation to figure out where your skeleton and joints are. We've got natural language processing, and some of our newer models include things like face mesh to identify facial landmarks, hand pose for hand landmarks, and of course our BERT Q&A model that allows you to do question answering natural language processing in the browser. So let's dive into some of these just to give you a flavor for what all these actually are and how performant they are in JavaScript. Now, the first thing I want to show you is object recognition. This is actually using COCO-SSD behind the scenes, which has been pre-trained on 90 object classes. And you can see here how it brings back the bounding box of various objects in a given image. You can see these dogs are coming back for this image on the right-hand side. Now, the key difference between object recognition and image recognition, of course, is that it gives you the coordinates, these bounding boxes. If we're doing just binary image classification, you wouldn't be getting this extra data back. So this is a more advanced form of that. So let's go over and see a demo of this in action. And if I share this tab, hopefully you can now see my browser web screen. And if I click on these images in the web browser, you can see instantaneously I'm getting that classification coming back in real time. So now I've classified these cats as well, just by clicking on the image within Chrome. Now if I enable my webcam, you can actually see that it's identifying me in real time as well as I move around my bedroom right now as I'm talking to you. And you can see how performant that is. It's all happening at very fast frames per second and is pretty robust. So in just a few lines of code, we're able to do models like this, which are very, very performant and super easy to use. So let's go back to the presentation. So the next one I will talk about is face mesh. This is just 3 megabytes in size, and it can recognize 468 facial landmarks, as you can see in a nice GIF animation on this slide. Now, this is very robust, as you can tell, but also it's very flexible too. In fact, Modiface, which is part of the L'Oreal group, have used it to do augmented reality makeup try-on, as you can see on the right-hand side here. So this girl in the image is not wearing any lipstick, but we've managed to augment lipstick on her lips using face mesh, essentially. And she can choose different shades and see what they look like on her before actually buying the lipstick, which is very, very cool. So let's go and see this in action as well. And if I switch to my other Chrome tab, you can now see face mesh running on my face in real time as I speak to you, and I can move my head around, and you can see how performant this is in the web browser. And the other thing you can notice here is that on the right-hand side, I'm able to render all those points in 3 dimensions using 3.js in the browser at the same time. So not only am I doing machine learning, but I'm also combining it with other web technologies, such as WebGL here, and we can actually get a 3D representation of my face being rendered at the same time. And now notice, this is running on my computer at about 25 frames per second. However, this is running using WASM, which is WebAssembly right now. And that means it's running on the CPU. So if I change this to run on the GPU by using WebGL instead from this drop-down, you can now see that the frames per second goes up into the 30s and 40s even, touching 40 frames per second. And now it's even more robust than before. And of course, we can actually use that in any way we so desire. Switching back to the presentation, next up we've got body segmentation. This can allow you to distinguish 24 unique body areas across multiple bodies all in real time. Now obviously this is a little bit tricky for me to demonstrate because I'm in my bedroom right now, but you can see from the animation here how it actually can segment these 3 bodies as they're moving around the room, and it even gives you an estimation of where their skeleton is for the pose detection. So that could allow you to recognize movement. And if you end now, these models that I've just shown you can be used for very delightful ways. And some of you I've seen chatting about my invisibility cloak. For those of you who haven't seen this, these are 2 prototypes I've created using the body pics model that we saw on the previous slide. And on the left here, you can see me walking on my bed. And notice on the middle image, I have been removed from the frame all in real time, even though the bed is deforming. So it gives you this kind of weird ghost effect, which is quite cool. And this was made in just 1 day, okay? So I didn't spend much time on this. And that is another benefit of prototyping in JavaScript. It's very, very easy to use. And there's lots of libraries and things you can get started with very quickly. Now, on the right-hand side, you can see something I also have created, which is a clothing size estimator. Now, I don't know about you, but if I'm trying to buy clothing, I never know what size I am. I'm useless at remembering my body measurements. So I made a tool that uses body pics to actually allow me to measure the key parts of my body, and then it can tell me what size clothing I need to buy on a given brand website. And again, this took me about 2 days of coding to create this prototype. So using these pre-trained models that Tensorflow.js have provided us, we can actually make pretty advanced tooling just by being a bit creative with our thinking and using these models in novel ways. And of course, this can even give you superpowers. So you can see here how someone's taken Tensorflow.js face mesh and combined it with WebGL shaders to give this Iron Man-like effect where he's shooting lasers from his eyes and mouth all in real time. And you can see how performant this is. It's all running buttery smooth in the web browser. And it's a really fun one to try out. And this is live. All the links can be found online after the show. And of course, if you go one step further, you can actually combine it with even more web technologies, such as WebXR, which is essentially the web's answer to augmented reality and mixed reality. And we do WebGL as well for the particle effects. And you can get this really beautiful example where this guy from Paris has essentially managed to scan any magazine if it finds a body in that magazine, we can then take that body and put it into the real world space, all in front of your eyes. And this is running on a mobile device, but you can see how performant it actually is. Cool. So how else can we use Tensorflow.js? We've seen out-of-the-box models, but sometimes once you've used those models for quite some time, you might want to then do transfer learning. And this is essentially when you can retrain existing models to work with your own data. Now, of course, if you're used to Python and other things, you can, like that, you can use code to do this. You can just write all the code yourself to do the transfer learning. I want to show you two easier ways to do that in the web. Now, first up, we've got a great website called Teachable machine that's made by some folk at Google that is really useful for making prototypes, just to see if something's going to work. And the best way to show you this is a live demo, of course. So let me just go over to my other tab here. And you can see here, this is the interface we're presented with. Now, all I have here are some classes on the left-hand side, and we need to add some example data that we want to be able to recognize. So I'm going to switch on my webcam for class 1. I'm just going to hold this button to record a few samples of my head in different positions. And you can see I've got about 35 samples of my head there. Now, if I go down to class 2 and enable webcam for class 2, I've got this deck of cards that are very handy on my desk here. And I'm now going to use this as the training data for the second one. So once again, about 35 images of that as well. And now I can click on train model. And what's going to happen here is that the ML model is going to retrain itself live in the web browser as I'm speaking, and in under 30 seconds, we'll get a live preview of the retrain model working on the right-hand side, and boom, there it is. So you can see class 1 was my face, and you can see the prediction here is indeed class 1. As I bring the deck of cards into view, you can see the prediction change to class 2 in real time. And notice how fast this is. So class 2, class 1, class 2, class 1. And that I just managed to make in under a minute, I believe, with you watching here on the live stream. Now, of course, this is great for prototyping. Maybe you want to just recognize something in your house or control your garage door to open and close automatically when it's light or dark, or whatever you want to do. You can make a cool prototype. Now, if this is good enough for your needs, you can click this export model button, and you can then use the resulting JSON file on your own website to then make a nice user interface and essentially use it for the things that you want to do. So it's super easy to use. Now, if we go back to the presentation, if you want something more robust for production, but maybe you need gigabytes of data to train properly, then you can use Cloud AutoML. Now, the reason I say this is because the web browser is typically limited to around 100 megabytes of RAM usage per tab. So that means if you've got more than that amount of data or size, then essentially you're going to have problems. So the best way to do this is to use Cloud AutoML to get around this problem. And you can see here, someone is essentially trying to recognize these different types of flowers, as you can see. And all they've done is uploaded loads of folders of different types of flowers into Cloud ML here. And then what we can do on the next page is simply define if we want to have higher accuracy or faster prediction time. And of course, this is always a trade-off in machine learning. You can have one or the other. So you can kind of specify what you want to optimize for. And then you click on train, and then a few hours later, you'll be able to download the resulting model. And what's happened in that is that the Cloud AutoML will be trying different models and different hyperparameters out for you. So it's essentially using machine learning to design the machine learning, which is kind of cool. And then you can download this resulting file. You can see here for Tensorflow.js, you can export to Tensorflow.js. That simply gives you this JSON file with all the data you need to then be able to use that model. So how do we actually use it in code? It's actually super simple. So here's all the code you need to actually use Cloud AutoML. At the top here, we're simply importing Tensorflow.js, and the second line is importing the AutoML library. And then you can see here we've got a global image on the third line here that we want to classify. In this case, it's a daisy. Now, the actual JavaScript we need to write here is just 3 lines of code. So the first line here, we're simply loading the model. So you can see here, tf.automl.load image classification. And we're simply passing a reference to the JSON file that we downloaded from the previous step. And that could be hosted somewhere on your web server, for example. And because this is an asynchronous operation, we simply await for that to return, and that will then be assigned to this constant called model. Now, we need to get a reference to the image we want to classify. In this case, it's our DAISY image, so we're just going to get a reference to the DAISY image in our document here, and assign that to the constant image. And then all we need to do is do model.classify, pass it the image we want, and await the results to come back to our predictions variable here. So all that contains is a JSON object with the various predictions it has found for the image that you passed to it. So you can now essentially use that in a super easy way on your own website, and then use that to do whatever it is you wanted to do. And of course, the third flavor of Tensorflow.js is to essentially write your own code from scratch. And if you're a machine learning expert, of course, you probably know how to do that in Python land already, and it's very similar in JavaScript as well. So obviously, teaching you how to write code from scratch in a 30-minute session is not going to happen. So for this part, I'm going to concentrate on the superpowers and performance gains you might get by writing in JavaScript. So essentially, in Tensorflow.js, we have two APIs. The first one is a very high-level layers API, which is basically the same as Keras. In fact, if you've used Keras, you'll be very familiar with the functions you can call in Tensorflow.js, as it's pretty much the same function signatures that you're used to. Now, below this, we also have the ops API, which is a more mathematical API, like the original TensorFlow, and this allows you to do all your linear algebra and all that kind of fun stuff to define your own new higher-level layers if you so desire. So putting this, pardon me, putting this all together then, you can see that we've got our pre-made models at the very top here. These sit upon the layers API, which is that nice high-level API we have, which then sits above the more lower-level mathematical ops API, and this can then essentially talk to different environments that we can run in. So you can see here, one of these environments is on the client side for things like the browser, WeChat, React Native, that kind of stuff. And each one of these environments understands how to talk to different backends. So all of them know how to talk to the CPU. That's our default fail-safe. But if you have a graphics card, then we can use WebGL to get graphics card acceleration. And this is really cool because essentially we're using the textures and things in computer graphics to do mathematics in order to get the graphics card acceleration, which is super, super cool. And we also support WebAssembly, WASM, which allows you to get better performance on the CPU if you so desire as well. Now, we've got the same story for the server side, and this is where we support Node.js. And you can see here that we have implementation for both the CPU and the GPU as well. Now, the thing that's important to note here is that essentially these are the same C bindings that Python uses behind the scenes. So performance is pretty much exactly the same, as we'll see in the next couple of slides. So you get the same CUDA acceleration and the same AVX support for the CPU that you're used to in Python land. So finally here you can see how this all comes together. You can import Keras models via our layers API. You can import Python TensorFlow saved models via the ops API, and you can do that without conversion if you're running this in Node.js. However, if you're going to try and use this in the web browser, then you'll need to use our TFJS command line converter to convert it to a JSON format that is digestible in the web browser. But essentially that's just a command line tool you can run, and assuming that the ops are supported, we support a couple of hundred of the key TensorFlow ops, then you can run that in the client side without any problems. Cool, so let's take a look at the performance then. This is for the mobile net model, and you can see here when executing on the graphics card with CUDA acceleration, in Node.js we're getting 8.81 milliseconds, and in Python we're getting 7.98. So the difference is really not much at all, and the same is with the CPU as well. There's really not much difference between the two. Now, what's interesting is that obviously in machine learning you often have to do a lot of pre and post processing. And in that case, you actually get an advantage with Node.js due to the just-in-time compiler that JavaScript has. Now, some of you may have heard of Hugging Face, which are quite popular for natural language processing, and they actually saw a 2 times performance boost by using Node.js due to the just-in-time compiler improvements for the pre- and post-processing. So for the inference alone, you can see that the results are very similar. But if you look at the whole stack, including the pre- and post-processing, then you can get a significant performance boost by running your code in Node. So looking at the superpowers for the client side then, and some of these are harder or impossible to achieve on the server side. The first one, if you're running in the web browser, is privacy. Everything that you saw running today in our demonstrations was running in my web browser on the client side. That means at no point were any of the images being sent to a remote server for classification, which is good because that maintains the user's privacy. And in some use cases, this might be a requirement, legally speaking, for medical applications or legal document reviews and this kind of stuff. And in some countries, you have like the GDPR laws and all this kind of stuff. So privacy you essentially get for free with Tensorflow.js. Second point, lower latency. Because no server is involved, that means there's no round trip time to the server. Maybe it's 100 milliseconds or more on a mobile device. That latency completely disappears, and instead we're actually accessing the sensors directly on device, allowing us to run things super fast. The third point is a lower cost, because we're not running any servers with graphics cards and processors 24/7. We can save potentially tens of thousands of dollars per month in server costs because all of that processing is happening on the client side. Fourth point, interactivity. JavaScript has a lot of very mature libraries for graphics and graphical user interfaces, things like D3.js, for example. These libraries are far more mature than in other languages due to the fact the web has been designed for the presentation of information since day one. And then the fifth point, reach and scale. Essentially, anyone can click a link on a web browser and run the machine learning without having to install anything themselves. Now, this is not true if you're trying to do this on the server side. The person will need to understand how to install Linux, how to install a web server, how to install TensorFlow and all the CUDA drivers, or then have to clone your GitHub repository for the machine learning that you want to run and understand how to use that as well. And not all documentation is very easy to understand. So you can see that anyone, even if they're not technical, can now run machine learning by running it in the web browser, which is much simpler. And that means if you're a researcher, you can now access potentially a much larger corpus of people to test that machine learning model that you might be creating out. So maybe you'll find bugs or edge cases that you didn't realize existed before when you only had 3 people on your team testing it in an environment that is already you're very used to. I guarantee if you put your machine learning model in the hands of creatives and people externally, they'll use it in ways you never even imagined. And this can be very good feedback to make sure your machine learning model doesn't have any biases. And of course, with JavaScript, we can support 84% of devices via the WebGL acceleration. If we're looking at Python TensorFlow land, we only have the CUDA acceleration, which means we are limited to NVIDIA graphics cards. In the browser, we can actually run on AMD graphics cards, on a MacBook Pro, or whatever you want to do. And we're not limited to just the machines with NVIDIA graphics cards. So that could be a benefit for you too. Flipping back to the server side, on Node.js, if you're running TensorFlow.js in Node, then we can essentially have the usage of saved models from Python without conversion. So if you do prefer to do machine learning in Python, that's completely fine. But if you're working with a web engineering team, they can then take that model and use it and distribute it within Node, which they might be more familiar with, in a much easier way. You can also, of course, run larger models than you can do on client side. Remember that 100 megabyte limitation for the web browsers. And of course, you can code in one language. If you already use JavaScript, this is a big win. In fact, 67.8% of people use JavaScript as their main development language, according to the Stack Overflow Development Survey of 2019. So if you are in that 67%, this could be a nice win for you. There's also a large NPM ecosystem of libraries you can use due to how long JavaScript has been around. And of course, the fifth point is performance, as we spoke about before. You get that just-in-time compiler boost for all that pre- and post-processing. So let's look at some resources you can use to get started. If there's one slide you're going to screenshot from today, let it be this one here. This one essentially contains all the things you need to get started. We've got our website and API, tensorflow.org/js. You can download any of the models that I spoke about today on our models repo here. And of course, TensorFlow.js is completely open source. So in that case, You can contribute if you so desire over on GitHub. We have a Google group, which is our discussion forum for more technical questions, which our team monitors. And we also have some nice boilerplate getting started code on CodePen and Glitch, which in just one click you can fork and have working JavaScript code that actually runs and does something useful. And then you can take that and, of course, turn it into something else as you desire. The book I'd recommend for this is Deep Learning with JavaScript. This book is very comprehensive, and even if you're not a machine learning expert, will guide you through everything from 0 to hero. And if you are a machine learning expert, then it does contain all those JavaScript nuances that you would want to know about, so you can convert your knowledge over as needed. So the only thing left to say here is please come join the community. Here's just a few demos that people have made over the last month or so. And some of these were shown at our recent show and tell. And if you use the hashtag #MadeWithTFJS for anything you create on Twitter or LinkedIn, that allows our team to find what you're making. And if you do that, then some of these may be featured on our blog or future TensorFlow events, which is kind of cool. And it's a great way to keep in touch with what everyone else is making too. So with that, what will you make? Here's one final example from a guy over in Tokyo in Japan. And essentially, this guy's a dancer, and he's been using Tensorflow.js to create these really cool hip-hop videos, as you can see from this animation here. So I'm really excited to see, now that machine learning is for everyone and not just researchers, where this might go in the next few years. The creative potential is really, really interesting. How will it be used in art, in music, in other creative ways? And it'd be very cool to see those come to life too. So if you want to stay in touch, feel free to add me on Twitter or LinkedIn. I post a lot of machine learning stuff there, generally speaking as well, and also JavaScript related. So if you're interested in any of those two areas, you can contact me over there. And for now, I'll check the chat for any questions as well. So feel free to ask a question in the chat, and I can try and answer that as well. All right, let's see what we got here. So can we use Teachable Machine to detect user interaction with the web? So I assume you're talking about using the webcam, or are you talking about understanding like mouse movements or something like that? Can you clarify? If you're talking about webcams, then of course, yes, you can use that out of the box. That's what it's designed to use. They can currently support recognizing objects from the webcam. They can do body pose estimation and also sound detection. Those are the three use cases for Teachable Machine right now. And of course, that will grow with time, but those are the three models that we support right now with Teachable Machine. If you're using to do other things like figuring out if your mouse is being moved by a human or not, then you'd have to roll your own model. But there's other examples you can use for that on our website.